Hey, thanks everyone. It's good to be here today. We don't get south of the border very often these days in Queensland. It's a busy title. Strategic Resources was a program of works we've done over the past few years. And new economy minerals is our current focus. It's really on critical minerals. But I'll explain that new economy bit in a bit more detail in a moment. And today I'll pick up on Dave's theme too around secondary prospectivity being the byproduct particularly of the primary mining phase, just as a subset of the broader works that we're doing. This idea of a new economy, it's important for government to get this right because it attracts funding from government to us, which is a good thing. So when we talk about the new economy in Queensland, what we're recognising is the global shifts underway in energy, industry, sustainability, but also geopolitics. Now that is creating, on one hand, huge demand for a range of minerals that wasn't really there in the past. But things like geopolitics is also bringing into play concerns about security of supply and the reliability of supply destinations. The world of sustainability is also driving changes in investor and customer markets particularly. You've probably all heard of various buyers like Tesla want to invest upstream, which is pretty unheard of, like a car manufacturer or a battery manufacturer investing upstream. It's a sign of the times and of the concern to lock in resources because there is a global race to secure the resources that we need, not just for the energy transition, but also for the new technologies that have been rolled out around the world, including in defence. So defence has a particular need for a host of minerals that they just can't live without. And rare earths are the exemplar of that. So new economy minerals, critical minerals, it's really a government term that we use because the new economy applies not just to minerals, but to the way we go about supplying those minerals. So not only the what, but the how is important. It also links to a concept that I'm sure you're hearing about around sustainable prosperity and the circular economy too. So circular economy thinking is on the rise, the idea being we've got to make best use of what we already have. The global population in 1800 was about 1 billion. It's forecast to be 10 billion by 2100. So from 1 billion to 10 billion in 300 years. That is putting huge demand on the earth, on our resources around the earth, our natural capital, our natural resources. We've got to find ways to be more efficient with our resources. And circular economy is really about resource efficiency. That's why we've got so much emphasis on this secondary prospectivity, making best use of what we've already got, what's already been dug out of the ground, crushed, processed, but left behind because there wasn't a market for it before. So circular economy, clearly a part of our thinking for the future. And what I'll focus on now is really this idea of waste being, in this case, mine waste. There's also e-waste, which is another great source of minerals. I'm just going to talk about the waste products, so to speak, from past mining activities. So our distribution of new economy critical minerals, there's a map there with some dots on it, you can read it for yourself. We've got a great distribution across the state. Our strengths are in copper, vanadium, silver, cobalt, tin, tungsten, indium, rare earths, across a variety of geological domains, as we just heard of from Dave. I'm not going to talk about those deposits per se. Of course, they're interesting and complex, but really it's around some of the work that's been done through our collaboration with the University of Queensland, particularly Professor Rick Valenta and his team, and Rick's here today. We're very thankful to work closely with Rick. We also work closely with a number of other institutions, GA, of course, University of Tasmania, Adelaide, ANU, James Cook, UQ, QUT. Our thinking is to bring the best minds together to solve the problems of the future. So we've got a great endowment of critical minerals, or in Queensland. In terms of mine waste, obviously we've been mining in Australia for a long, long time, and there's various types of impact from that mining, from just where people have scratched around looking for something in the past, through to significant legacy sites like Mount Morgan in Queensland. So there's a host of opportunity in those former mining sites to extract the critical minerals that have been bypassed from them in the past. Now, I'm going to draw heavily on the work that UQ and particularly Anita Prabhakar-Fox has been working with us on. She's a leader in the field of secondary prospectivity, so I'm very thankful that I can copy that work. So distribution of minerals across Australia and these old sites is a huge opportunity for us. If you look at some estimates around what's in these tailings globally, the numbers are pretty staggering. So you can see there some really, really big figures around, what's been left behind, basically, in tailings and so on. So, there's billions of cubic metres of waste material. It's unbelievably huge. 200,000 tonnes of tailings material is produced each day globally. So a similar amount of waste rock. And if you consider the waste rock, the material that we use most of on Earth is sand. And believe it or not, sand is in short supply for construction, because you've got to have a certain type of sand. It's got to be angular. So your desert sand is no good for making concrete. Sand, so there's a lot of movement these days to turn tailings into sand, because sand, as I say, is in such incredibly short supply globally. There's even a sand mafia in India who move into your property, steal the land, basically, take the sand away. Secondary prospectivity, that's a term we use. It defines opportunities where the commodities have already been dug up and are being stockpiled. They may have been bypassed during the primary processing phase or abandoned because they weren't economic or operational to extract in the past. By studying secondary prospectivity, we aim to define the potential value, particularly of the metal components of those tailings. And in Queensland, for example, our biggest opportunity is in cobalt, in tailings material. Now, in the Mount Isa mine itself, there's no public cobalt resource that's been disclosed by Glencore, but we do know that some of the spot grades there are up to 9% cobalt, sitting in their tailings dams, 9%. Now, we know that mostly occurs in pyrite, and there is historical cobalt production. So I've got to read this because this is meant to be Helen's presentation. From Mount Isa in the 1990s, they're producing cobalt, but that dropped away when the price for cobalt dropped away. In terms of the volume of material in Mount Isa, it's 15 square kilometres, the tailings area. We don't quite know the full volume at depth, but it's a significant amount of potential there. They clearly, we're very keen to see Glencore make best use of that tailings. At the moment, what they're doing in part is really injecting it back underground as a paste. So that would be a huge lost opportunity and absolutely contrary to the idea of the circular economy. The other work we're doing in cobalt, once again with UQ, is looking not just at copper tailings, but we're also looking at rare earth elements in IOCGs, in phosphorite, once again, as Dave has already pointed out, looking at indium in tin mine waste, gallium and germanium in zinc ore, and many more. The project that we've been doing with UQ, and Anita in particular, is running for a few years now. I don't think we've even had the results back from the first round of sampling before we've garnered huge international interest in the work and buy-in from external parties. I'll share some of those results in a moment, but it just goes to show how important and how topical this idea of critical mineral endowment in mine waste is becoming. So this year, we've also begun working more closely with Geoscientists Australia and others on the opportunities in mine waste, once again, as Dave was outlining. GA, of course, have a nationwide mandate. So the inventory is expanded to include sites across the whole of Australia. Once again, Anita from UQ is working with GA to ensure that a national standard for such analyses is developed and adhered to. When we talk about mine waste, there are quite a variety of different materials to consider, such as waste, rock dumps, tailings, of course, that's the obvious candidate, spent heap leach, slag, red muds from bauxite, and various forms of coal mine waste, believe it or not, including coal wash and fly ash from coal-fired power stations. I've listed here some opportunities in the mine waste space that we have or will be examining into the future. In the first 2 years of the program, we spent a lot of time looking at traditional metalliferous mine waste. However, we plan in the coming sampling round to include red mud from bauxite processing and coal fly ash. We know, for example, that at least one of the coal fly ash dams in Queensland contains significant rare earth content. So it's an interesting area of focus for us too. To put all that in context, here are all the sites we've looked at so far across Queensland, 17 in total, with many more to come. I'll draw your attention to the Rocklands area here near Cloncurry in the Northwest Minerals Province, which we'll discuss more in a moment. Capricorn Copper is another site which is subject of a more detailed investigation. You'll note too that there are some very big mines missing from the map, Mount Isa and Ernest Henry, for example. We're still in negotiation with Glencore to get access to those sites. I also want to acknowledge an important collaboration that we entered into last year with both our colleagues at UQ, but also with the Japanese government resource security agency, JOGMEC, Japanese Oil, Gas, Metals National Corporation. We signed an agreement last year in October between the three-way agreement. The idea is to jointly study the problem of cobalt extraction from pyrite, understanding that this is a key mineral host for cobalt in Queensland's copper mines. But the results will be applied globally. The opportunity is also specifically focused on mine waste, because in the copper mines of northwest Queensland, including Mount Isa, as well as Rocklands, pyrite is one of the main sulphide phases that are separated out to go to the waste and is therefore concentrated in the tailings. As you all know, this creates its own issues in the form of acid mine drainage. This map shows all the site samples so far, with locations coloured and sized with cobalt concentrations. As you can see, and we'll see further over the run of ensuing maps, we get distinct groupings of metal content depending on the source region, geological setting and deposit type. The highest cobalt values all occur in this area southeast of Mount Isa, which is dominated by IOCG systems. The lighter green dots seem to show up the sediment-hosted and epigenetic systems in the west and east respectively. Note the locations of Rocklands, which we've discussed, as well as Osborne, which show the highest cobalt concentrations in all the tailings and mine waste analysed so far. Here's another look at cobalt with mean values from each site. The yellow line here, The yellow line here pulls out the group of IOCG deposits, so they really do play a key role for cobalt in Queensland. As I said, the highest cobalt values are from the Osborne mine tailings. There's an image of those tailings here on the right. Chinova, who holds the Osborne mine, have produced a copper-gold resource on the tailings, but unfortunately didn't include cobalt. The two circles on this graph represent sites that are subject of much more detailed research than the others. Capricorn Copper shows relatively low cobalt. However, this is on the basis of sampling at the surface of the tailings. Whereas we know throughout historical throughput has included some fairly high-grade cobalt material. So we suspect the tailings dam at depth should have pockets of higher cobalt concentrations. And Rocklands is, of course, the site of a collaboration with JOGMEC. Moving away from cobalt, I'll give you highlights of some other commodities to show opportunities for mine waste reprocessing. Here is a distribution of rare earth elements. Once again, IOCG corridor plays a big role in the deposit chemistry, though we've also seen some of the intrusion-related deposits in the northeast in anomalous rare earths. The high-grade pink one here is the Mary Kathleen mine, which is an abandoned uranium mine that would be really great to recommercialise. The main ore phase at Mary Kathleen is allanite, shown in a QM scan image collected by John Maverick Jeans and team at ANU, who are also working with us on this deposit, but more looking at the primary ore, which this image represents. Another group at the University of Queensland is working with GSQ to define sustainable methods of rare earth element extraction. That work at UQ, the metallurgical team there are trialling, for example, bioleaching, the use of bacteria, and phytomining using hyperaccumulator plants to test for more sustainable methods for rare earth extraction than are currently available. This acknowledges that a lot of rare earth ores are dominated by quite refractory minerals such as zircon, monazite, and potentially allanite. The experiments that you can see here are underway and hopefully we'll have some good results to report in the next year or so. They're also testing a variety of other rare earth types in Queensland, such as rare earths bearing phosphorites, heavy mineral sands, and peralkaline volcanics. Here's a map of the indium concentration in the intrusion-related tin system in northeast Queensland. Indium is a rather underappreciated metal. It's important for a range of technology and electrification applications, such as all sorts of screens and solar panels, as well as transistors and microchips. Global demand for indium is predicted to grow by 240% by 2050. Current global production is very small, and although Queensland doesn't actually produce indium at this time, we have some of the highest grade deposits in the world. As what industry is doing, it's true around the world, as well as Queensland, the companies have been picking up on the opportunities in mine waste. However, this does seem to have had a resurgence in recent times. New Century Resources has acquired the Century Zinc Mine, north of Mount Isa, in 2017, for the purpose of reprocessing the tailings, which are estimated to contain 77 million tonnes of zinc. And the zinc is extracted and the new waste put into the old Century pit. Similarly, on Queensland's east coast near Cairns, EQ Resources and global metal company Chronomet, based out of Germany, are joint venturing on the reprocessing of the abandoned Mount Carbine tungsten mine tailings and mine waste. The key thing with both of these examples, Mount Carbine and Century, is that the companies are very focused on the reprocessing of waste to extract the original commodity that was mined. Neither company is looking at the opportunities for other commodities just yet that are associated with the primary metal of interest, in this case of tungsten or zinc. And here is a rather busy summary of the new economy minerals we have focused on so far in the study and the primary waste types that are important in our secondary prospectivity model. Of course, as waste is ultimately derived from a primary source, it is a reflection of the original ore types. What we see, however, is that superficial processes come into play, such as weathering and oxidation. Tailings piles can be quite stratified depending on not only the variability of material through the mill, but also on the interaction between the tailings material and the water table. Therefore, surface sampling certainly does not reflect the mineralogy of the entire potential of the tailings material. A major component of our research on waste involves analysis of the mineralogy, deportment of the critical minerals at the selected sites. Investigation of bespoke processing solutions, such as the bioleaching and phytomining methods that I've mentioned before. Finally, I just wanted to look at this slide you may have seen before from Ernst & Young. It has the top 10 issues. This is from 2021. But this always brings us back, I think, to the circular economy and to the role that minerals and metals have in the concerns globally in that space. In these top 10 risks that EY have identified, It's updated every year, but license to operate is the number one concern for companies globally. That feeds into the idea of that ESG investment, environmental, social and corporate governance investment, is a key feature of the resource sector today and into the future. By taking a whole ecosystem view of opportunities, rather than pure geology, economics, and a traditional approach to value maximisation, we can help set the mining resource sector up for the future, the adoption of the circular economy and sustainable prosperity principles. Visibility of supply chains, processes and their impacts is more important than ever before. Government agencies have a really strong part to play in supporting the industry to embrace these changes. And I think the traditional geological surveys will need to remake themselves to incorporate concepts such as secondary prospectivity, minerals traceability, provenance, and credentialing. It all talks to the future of the resource sector. Thank you.